Welcome everyone. Welcome back to Devoxx Belgium. I'm here with Alan Bateman.
Hello, good morning.
Yeah, morning Alan, thank you for being here.
Yeah, no, it's great to be here again.
Yeah. So for those few people who don't know you already, let's quickly introduce yourself so they know who I'm talking to and why.
Okay, so I'm working on the JDK in Oracle. Have been for a long time. So I'm currently focused on Project Loom, but people will know me from a lot of other things over the years, including things like modules and some of the work in the NIO and many other areas of the JDK over a long time.
Yeah, okay. But you're here, I think, primarily to talk about Project Loom, right? The next phase of Project Loom?
Yes, I have a talk on Friday. Last slot.
Last slot.
Last slot.
I think that's kind of an honor, right? The last slot is usually kept for an important topic so that people really stick around. So that's like
Well, I can interpret it one of two ways. It's an honor that you actually keep people to the end, or you put the uninteresting stuff at the end. But we will see. We will see how many people show up.
Often Brian closes out, so I think it's the first.
Right. Brian usually. Yeah. Yes. Yeah.
So what?
Then just years guidelines.
Yeah.
So for people that actually are trying out virtual threads, there's a whole bunch of frameworks already have a good story around that.
Yeah.
I want to talk a bit about bringing those systems into production and what it actually means to be able to actually diagnose problems and manage applications with very, very high volume, for high, let's say, large number of concurrency. So I want to talk about the diagnostics features. I want to talk about serviceability, monitoring, management, that kind of stuff.
That's a lot for one talk.
Right. Well, just to even quickly just go through these things and make people aware of what's there now and what things are actually coming, because we've actually made some good progress on that topic in JDK 24. And then for the second half of the talk, I want to talk about...
That's just the first half.
That is just the first talk. So I can't go into everything, but second half of the talk, I want to talk about structured concurrency.
Yeah.
Because we have made good progress there, but it's an area where we need to get a lot more feedback on this API before we actually make it a permanent feature. So I want to go through where we are on that. We have a revamp of the API coming, the Victor Klang, and I've worked on over the last year, and that's in our early access builds now for a while. So I want to go through some of the examples using that, and that's kind of mostly the talk.
Okay, nice.
The nice thing about being at the end is maybe I won't be time constrained.
Maybe.
We will see. We will see.
So, by the way, for those people who find all of this very interesting, the talk will be on the Devoxx YouTube channel, also eventually on the Java YouTube channel. So whatever channel you prefer, make sure you're subscribed, and then you can see that talk in full. We could just have time to dip into a little bit here. One thing that I think you didn't mention just now, but I saw in the abstract was, and that's something that people have been interested about, is the concept of the issue with pinning and synchronization. I think that's something that many people who adopted this early are aware of. Some of them actually ran into it in practice. So maybe give us a little bit of a short rundown what that problem actually is, and then maybe what the progress has been there.
Okay. So the way virtual threads work is they actually have to run on a platform thread or an operating system thread. So the term we use when we actually connect these two threads together is mounting, and when the virtual thread executes then on this platform thread, it then invokes does something with locking or an I/O operation. You actually have to unmount it, and you release your underlying thread to go and do other work. There are cases that arise particularly with the synchronized keyword, synchronized methods, synchronized statement, where you can't release the underlying carrier to do other work.
Okay.
And we refer to that issue of pinning. The virtual thread is pinning the carrier.
Okay, so they're now bound together, and if you would want to unmount later, you can't.
Exactly.
Okay.
Exactly, and that creates a scalability issue. It can create a starvation issue. Now you might say, "Oh, why did those Oracle guys go and make this feature a permanent feature with this limitation?" But when you think about it, virtual threads are all about increasing concurrency.
Yeah.
We've 1,000 different threads executing things that are completely independently.
Yeah.
There shouldn't be much contention, or there shouldn't be much interaction with locking between multiple virtual threads. And that is mostly true, but there's a lot of libraries out there. We have essentially 25, 30 years of libraries out there.
Yeah.
And there's a lot of use of the synchronized keyword.
Yeah.
And there are people that are using libraries, for example, for things like pooling database connections. And the underlying library is actually using monitors and to be able to give out permits for connections to the database.
Yeah.
So 1,000 virtual threads are actually using that one library, maybe actually having some contention.
Yeah.
So you run into kind of issues there. And the starvation issues can actually lead to deadlock situations in some scenarios, particularly when you actually start mixing the synchronized keyword with Java util concurrent locks. And we've had a few reports of that. We've kind of understood this issue for a long time.
Yeah.
But when we talked more than a year ago about making this a permanent feature, it would be better to make this feature permanent.
Yeah.
Rather than waiting another 2 years and solve this problem.
I mean, like, we probably don't know what percentage of projects that would like to adopt virtual threads can't because of this issue, but even let's just throw some number out there for ease of talking about, let's say it's 50-50, which I don't think it is, but let's say it were 50-50. Well, you made it permanent, so at least half can now already use it, and the other half are waiting for a fix.
Right.
And I don't think it's 50-50, by the way. I think it impacts fewer projects, is my guess.
Right. I don't think anyone has data on the number of projects, but it's a concern for people, and it's now become kind of widely known. If you look at any conference schedule, someone actually has a great talk about this particular topic. Okay, so a couple of things to say is one is the JDK actually has a number of ways to diagnose these issues. In JEP 444, which is the JEP where we make this a permanent feature, is we actually explain those diagnostic options, and we also give some guidelines in that. For example, if you've got code that's doing I/O operations while holding a monitor, then this could be problematic, and you can actually migrate that to Java util concurrent locks. In the JEP we talked about moving to reentrant lock, which is semantically equivalent to an object monitor.
Right. So the idea is to replace synchronization with those explicit locks.
Right. Exactly. Now it's a little bit embarrassing to ask people to do that kind of replacement, but that is how you work around that issue for the moment.
But I personally have to say I don't use synchronization lock because it turns often when I run into concurrency issues, I feel like I start with synchronization and then it works for a while and then something changes and then it stops working. So I really for myself realized I usually use locks. So I really look for what's the right lock here and start with that.
Well, it tends to be a kind of an advanced feature, and sometimes you find in libraries as well as they're over-synchronized, so the scope of the lock is longer than, and it usually requires quite a deep understanding to be able to know exactly where you actually synchronize on.
Yeah. Okay, but
it's not an issue for things like that are just using object monitors for. Just some data structure, and they're modifying fields. They're just using it for mutual exclusion while they've got some mutable object.
Yeah.
It's mostly an issue for I/O inside of synchronized methods. That's sort of the 90% of what we see.
Yeah, right. So maybe it's important to drive that point home. Pinning is only an issue when you want to unmount, but when you just manage in memory internal data structures, you don't want to unmount anyway. So it's not a problem. Unmounting, so pinning becomes a problem when in the synchronized block you do something like I/O, like make a web request, where you would want to unmount.
Exactly.
And that can happen. But still, I think there has been improvements in this area.
Right. This is something that's been worked on for quite some time.
Yeah.
We've had early access builds starting with February this year. This is actually going on quite some time, which actually provides relief. So we did this in a couple of phases.
Sorry to interrupt. That's a Loom early access build or 24?
Loom early access builds.
I
should be clear. Yes.
Yeah. Okay.
So we do have a number of people actually do follow the Loom dev list and help us test out Loom early access builds, which is good. So this allows us to test features before we propose them for the mainline. So we have a solution for object monitors and synchronization in these builds for quite some time. There's sort of three aspects, but I won't go into the details of all that there. But it covers It covers being able to unmount while you're in a synchronized method. It covers the scenario where you actually get contention on a monitor. It covers the object weight as well. So, looking quite good. There's one little performance niggle that will have to be worked on later on, but it is not a correctness issue. We're confident that it fixes the pinning issue. So that's good. So we have a JEP. So the JEP is currently on the technical roadmap as JEP 491.
Okay.
And we are hoping, fingers crossed, toes crossed, that we will get this into JDK 24.
I'm doing the talk crossing too, but you can't see. Okay, so 24 would be the hope
that's
nice.
what we hope. So as I said, we have early access builds out there, and we're really hoping just to get more people actually testing them out. I realize that people that are testing early access builds is not something that's part of their normal day job, because they're working on their own projects, their own applications, whatever. But any help that we can get testing out those builds are very, very useful, and several people have actually been quite good and showing up and reporting back. So that's good.
So that's something that we've been saying in talks about OpenJDK. Shar says that when he talks about how to contribute to OpenJDK, how the community can contribute. Just plain out the best way to contribute is if there's a feature that you think you want to adopt once it's done, look into early access builds for that. That could be pattern matching, that could be Valhalla, that could be Loom. Pick those early access builds and run them through the ringer. Like really try to use it as you would in practice. For example, for Loom, ideally you have a big battery of performance tests or just like simulation of how your whole app runs, and run that with early access builds, and then let us know. Let OpenJDK know how that works.
Exactly. So you could have an entire podcast just talking about contributions, but contributions in the form of good bug reports, or contributions in terms of testing out some feature or language feature where you've actually tried something in earnest and here's your actual feedback, rather than, oh, well, I liked your API, but my API is better. When we talk about that instead, that kind of feedback is useless. But the feedback for people that actually have tried things out, what is actually proposed, try it out with something real, and try out a Loom early access build and try it with the applications that you've had trouble with. That is actually so useful to the project. It's a
real world experience.
I would actually say that it's a better contribution than showing up with a patch to add some other feature that you want. It's so much more valuable to the JDK.
Cool. I have more questions, but let's look whether chat has anything to say. We have a question, what is the future of Java in coming years? We have, thank you for that question. At this point, I want to say 6 hours and 45 minutes. So at 5 p.m. 5 p.m. Central European Summertime or 3 p.m. UTC, we'll have Gavin Bierman on. I think that's this afternoon to talk about the Java language futures. So that question would fit better to that stream. So I'm going to skip it here. We don't have anything else from the audience. So I wanted to ask. You mentioned when you ran through through your talk, serviceability improvements.
Yes.
And so what's that about?
Okay, one of the wonderful things about Java Forever is stack traces, thread dumps.
I mean, most people don't quite think that maybe because we only encounter them when we have a problem, but it's good that they're there.
Right. Their importance is underestimated. The Java stack trace it tells you so much. Having line number informations, seeing the method and the class and the method name for each of the frames, that is so valuable. And thread dumps have grown over time to include a whole bunch of stuff that is interesting for diagnosability purpose. So really important tools for people who are actually managing production systems. But there's so much. So what I would say is that we've had 25 years of adding features for platform threads. And here we're starting again with these other type of threads. What features have you for those? So I want to go through that topic.
Okay.
And so we already
can you give us an example? Like
right. So we've done quite a few things. So for example, we've already put in a new thread dump that's actually parsable. That includes all the virtual threads. When I say parsable, it's in JSON format, so tools can easily consume it. We've been able to get virtual threads now into the heap dump. That was a challenge to get going first. We've got diagnostic features I mentioned earlier on for pinning. In our early access build, we've actually extended these again with additional JDK flight recorder events. So they're actually quite useful. A lot of developers wouldn't be familiar with the JDK flight recorder. It's like, oh, it's this thing they never heard of, but they haven't tried it out. But it's actually extremely powerful.
Yeah, and it shows up more and more in some of these more VM-focused features. That there's a good way to diagnose things. Also for some of the deprecations, you can get something that deprecates for removal. You can get flight recorder things. So yeah, if you're at all looking into your app while it's running,
so there's a whole bunch of things that we can talk. So for example, we've added a new monitoring and management interface for the virtual thread scheduler in JDK 24 that allows JMX-based tooling to actually get an insight into the scheduler, the number of virtual threads that are mounted and queued.
Okay.
You can even do dynamic control of target parallelism. So in containers, when you can actually do a dynamic adjustment of the target parallelism to match the.
Oh, you mean like the things that I would I know that there are command line flags with which I can.
Yes, that's actually so there's command line files configuring it, but it can also be changed dynamically as well.
Okay, that's pretty cool.
So that's interesting. Okay. We've also got other command J commands, so that's another troubleshooting tool that is in the JDK for a long time. In the old days, people would have heard of JStack, JMap, JInfo. That got superseded some time ago by JCommand. That's JCMD. Yeah. And that's basically the front end to whatever you're having yourself type of diagnostic feature. There's a whole big long list of commands that can be added there to give you all sorts of insight into what is going on in the VM. So we have in our early access builds a new command there that actually gives you an insight into the scheduler, timers, I/O sockets. There's a whole bunch of stuff that actually is in there, so it's actually quite useful for when diagnosing a problem. Big projects that we have got to get done over the next while is improvements on showing lock information in thread dumps, deadlock detection, that kind of thing. So thread dumps are traditionally very, very good at actually seeing what's going on with the synchronized keyword. You can actually see which threads are
holding a monitor.
Yes, you can. It tells you which frames are holding a lock. You can tell you what the thread is waiting on a monitor. You can actually see. It gives you like a hex number which is the identity, but probably not too useful in terms of what the value it is, but gives you an idea for matching it up in the thread dump. Okay. So we need to extend this and figure out ways to get this to work with some of the ownable synchronizers that we have in Java Tool Concurrent.
Okay.
So there is slow ways to doing that today, but we need to come up with better ways to do all of this kind of thing. And that becomes more and more important with virtual threads. Because with virtual threads, you've got a lot more threads. Yeah. And how do you even visualize that?
How do you relate information across 100 threads is different from across 10,000
exactly.
threads.
And this comes back to things like parsable thread dumps, because if you've got 10,000 or 50,000 threads, that's something that you can't just, here's my thread dump and here's all these stacks. It has to be something that's consumable by tools that can actually do deduplicate stack traces, deduplicate based on the stack trace, and be able to show, there's 49,000 threads are actually here, and then there's these other small number of threads that are actually doing something more interesting. That kind of thing. Other thing with structured concurrency, then we've actually fits into all of this in that with structured concurrency you end up with a potential tree of tasks, and that's actually all goes into the thread dump. You can actually reconstitute that tree from the parsable thread dump, which is actually quite interesting.
For those who don't know, when you have structured concurrency, basically you're saying this virtual thread now starts these other threads,
exactly,
and it will not continue until they're done, and that builds like this tree structure where threads are not just like strangers in the night meeting and passing information, but have a parent-child relationship, and that builds a tree, and that is extremely powerful. I'm actually showing that a little, at least like a tiny bit in my talk about modern Java in action.
Right. My apologies. I did not introduce structured concurrency before bringing it up on that topic, but you're exactly right. One thread decomposes and splits into a number of other other tasks that are executed by threads. Virtual threads are brilliant for that, and then they themselves might decompose again, so you end up with that tree structure. Yeah. How do you visualize that? And that's something we have been working on.
Cool. Thank you very much, Alan. So again, for those of you interested, the talk will be online on the Devoxx channel, on the Java channel. Also another talk that, since you talked about JCommand and the JFR, My colleague Anna Maria Mialciano, she has a talk here about different tools, different of the JDK tools. I think she's also working on more about that, but I don't want to spoil a surprise if she's ready to give it. So yeah, look into that talk, look into the commands if you're interested in all of that, and I'll see you again in a couple hours for the talk to Gavin Bierman. Thank you very much for being here, Alan.
Okay.
It was a pleasure to have you.
All right, nice
Have a
being
good
here.
one.
Okay, thank you.
Bye. Bye.